Of course, you can't go handing out plastic products to an injection moulder without them immediately inspecting the thing, reverse engineering it and figuring out how it was all made. What I do know is these are made out of polypropylene, which is a nice flexy material. It's what's used on living hinges, so a lot of caps and closures make use of polypropylene because it's pretty fatigue resistant. You can bend this stuff back and forth without it breaking, and if you've ever tried chewing the cap off a big biro, you'll know that the stuff is pretty much indestructible. It's also a very cheap and easy material to work with, fully recyclable, and I imagine they're getting fairly fast cycle times on this. Having looked at the lugs on the ends, they do line up with the holes on a ring binder. These two do, and these two do. So they're obviously using a standard hole punch on an acetate sheet to fit the face guard. They're not making the bottom part that goes with the face guard that is on the Prusa design. They said basically it wasn't needed and it would be an extra mould. Interestingly, the two centre pips don't line up. I thought they might have used one of the 4-ring hole punches to do this, and certainly on an A4 sheet of acetate there's enough room to do that. It did occur to me that maybe they were doing it horizontally and so they're limited by the length across, assuming these are A4 sheets, but that doesn't seem to match up with the dimensions here either, so I'm not 100% sure why these two are different, but presumably it's not too much of a problem to get things lined up and get the thing to fit once you know what you're doing. So anyway, the first thing that any moulder is going to look at on a product like this is where the ejectors are, where the gates are, where the parting line is. Maybe if I zoom down a little bit and adjust the focus very slightly. There we go. We can see on this side there are indeed some big dots here, and there's another one over here, and these are obviously the classic ejector pin sites. So this is going to be on the moving half. This is the bottom of the part. There's also these little pips here, which are again ejectors, and there's one right here on this lug and also one here. Now originally when I saw this I was wondering what these little standoff features were. I thought they might be something to do with the way they were fitting the elastic, but on closer inspection that's just added so they can get a slightly bigger ejector pin there rather than quite a small one which would be needed to go on here. The smaller the pins are, the more likely they are to get twisted and bent, and it doesn't happen very often. And there's another one here right at the intersection. So that's how they're getting it out of the mould. If we look on the side, if I can twist this over, we can see there's a parting line here, dead centre, and that runs all the way around, and that makes sense when you consider that these pips would have to be parted dead centre, otherwise you would have an overhang and an undercut on the mould and you wouldn't be able to get them out. Wherever possible you would normally put that parting line slightly to one side, so instead of having it dead centre you would offset it, so that would put more geometry into the ejector side and guarantee the part will stick. But they've not been able to do that here because they've got these features dead centre, and that kind of mandates a central parting line, otherwise you're going to run into difficulties. The gate is actually on this edge. I might need to go up a little bit so that we can see under and see where this gate is. There we go. Maybe if I can adjust the zoom and get the lighting just right. Struggling a bit here. There we go. Just there is actually the gate point, which is there, a slight dot, and that's below the parting line. Normally you might expect to gate it directly on the parting line, but in this case they've gone down and dropped it a bit lower, and the reason for that is they've probably got this on a two-cavity mould. So there's another one there. I'd need to email them and check, but it would make sense. And then there would be a feed sprue in the middle with an ejector pin underneath it and two little submarine as they're called, gates going into the steel itself, kind of dug down into it, hence the name, and then they'll be on a curve so that when this pin fires it will push that pin out, drag them out of the little channels that serve as the runners, and then break it off nice and clean here, and then these would obviously pop out. So I expect that's how they're doing it. You could have potentially gated it on this side and had a single cavity mould, because remember the feed on the mould is going to be dead centre of the plate, and obviously if that's dead centre of your mould, you've got this up here and then you've got all this dead space on the other side, so a 2 cavity would make sense. Or alternatively you could have gated it here and had a single cavity mould, which is less to cut but then less throughput as well. But then you've got to flow all the way around here and back, and then back down on these wing portions as well. So considering how the plastic has got to flow, here is possibly a better place to do it, because then it's going to sweep all the way around and only has to come back to here. There's probably going to be a weld line here. It's not enormously conspicuous, but they're probably running this on a fair size mould. I can kind of see a little bit here. I don't know if I can even catch that in the light. Maybe there you can see that there's a very slight line across it, which would be expected because the plastic's going to bifurcate, go all the way around and back from both ways and meet here. So I'd expect there's probably a bit of venting here as well, but that's going to be so small that it's pretty much invisible. So I think that's most of what they're doing. It's a relatively simple mould. It's all clearly been machined in, even these side panels. Oh yeah, the sides, if I zoom way down on this, get about as close as I can and readjust the focus, if I can just pick that top surface up, there we go. Just on the edge here you can perhaps see these lines, and that's where the cutter has gone back and forth, back and forth, back and forth, cutting down this geometry. I don't know what size that is, probably a 2mm slot drill by the looks of it. So that's how they've actually machined this in. It's not been spark eroded, which, well, that would have just been making extra work, I suppose, because you've got to cut an electrode to make all of this, and that would have taken some time as well. So probably easiest just to machine it in. I don't know if they're using a steel mould or an aluminium mould. You can certainly get tens of thousands of parts off an aluminium mould these days, so maybe they've taken that path because it's quicker and slightly easier on the machining. But from what I've heard, the mould is going back in this afternoon and they're doing some more, so it's still running fine and still chucking them out and doing its bit for helping out in the current crisis. One additional feature that I didn't pick up on initially is there's a slight taper on this half, which is in the fixed half, and it's flush on this side. So that makes sense, because obviously you want it to grab on the back where the ejector pins are, but pull easily out of the fixed half mould. And if I actually get in there with a pair of calipers and measure that, that's 2.27, so maybe a 2.3, and if I come in from the other side and measure it down on this edge, if I can just get it, that's 1.9. so that's obviously been cut on that side with a slight taper cutter with a small radiused corner, whereas this side has been cut with what appears to be a fairly flat end slot drill. So an additional little feature there which I should probably have picked up on earlier, but anyhow I thought I'd draw your attention to that for completeness.